Welcome to part 2 of 2.7, Solving Inequalities. So we're going to use what we learned to do some stuff. So right here, we want to graph and write the solution set both in set builder and interval notation. Now, this right here is a solved inequality. And once you've solved an inequality, much like an equation, you'll notice that the variable's just on one side. So to put this in set builder, put a line, a y in front of it, and then we put set brackets around it. Now, if we think about this, y is greater than or equal to 5. The point of interest is at 5, so I'll put a little line with 5 there because we have greater than, not greater than or equal to. We want an open circle, and because y is greater than that, we shade to the right here. So putting this in interval notation, the solution set to this starts at 5 but doesn't include 5. So we have a parenthesis and not a square and bracket. Put the 5 there, the infinity, and then we're good. So that's exactly what we do right there. Now, same thing for the second one. If we're going to put this in set builder notation, the second one's already solved, so we put a line here, an x, scribble, and we're good. Now, if we look at putting this in, there's two conditions on this. One, x is greater than or equal to negative 5. So on the number line, I'll put a little mark at negative 5, because we have greater than or equal to, we have a solid circle there. Also, x has to be less than, or just less than 2, so our point of interest there is 2. Less than, open circle. So we're thinking about what numbers are bigger than negative 5 but less than 2. That's that interval right there. So closed circle always means bracket because we're including negative 5. That's part of our solution. In fact, negative 5 is less than or equal to negative 5. So we start at the lowest number and we read from left to right, go up to 2. Put a parenthesis there because we're not including it, and that's how we do that one there. So these next couple, we're going to solve these. So what we want to do is isolate the variable. So on this first one, we're trying to get y alone. So if we add 9 to both sides, we're going to get y is greater than negative 15 plus 9 is negative 6. So now that we've isolated the variable here, we've solved this inequality. Put this in set builder. We put a line, our y, and scribble. Now, if we thought about the graph of this, which we don't need to graph it, but sometimes the graph helps us put it in interval notation, our point of interest is negative 6. Y is greater than negative 6. So if this is negative 6, greater than, we have a circle. Y being bigger than that means we're going off this way. So the interval here starts at negative 6 but doesn't include negative 6. So parenthesis negative 6 to infinity, and that's that one there. Solving the second one here, we subtract 2 from both sides, getting the x all alone. So here we get cancellation. Our 3x is less than or equal to negative 6. Then, of course, 3x is 3 times x, so to undo multiplication, we're going to divide here. Divide that out. The 3's cancel. And we get x is less than or equal to negative 2. So thinking about that as a graph, there's negative 2. Because we have less than or equal, we want a solid dot right there. And x being less than or equal to it, we're shading to the left. So putting this in interval notation, we're starting from over here, so it's the interval that goes from negative infinity, and we read from left to right all the way up to negative 2, or including negative 2. So we put a square and bracket around that, and that is exactly how we do that. So moving to the third one here, you'll notice that we have y's and numbers on both sides, so we want to get our numbers on one side and y's on the other. The other thing we want to do is combine like terms if we can on an individual side, and you'll notice over here we have a 5 and a 2. If we add these together right here, we just have plus 7. So just went ahead and combined like terms there. So here we have our 9 minus 8y. Over here we have a negative 7y plus 7. So what I'm going to do is I'm going to move my y's to the right, so I'm going to add 8y. So if I'm moving my y's to the right, I need to get rid of this 7. Since we have plus 7, to undo that, we're subtracting 7 from both sides. So over here, 9 minus 7 is 2. Negative 8y plus 8y, we get cancellation. We're not multiplying or dividing by a negative, so we don't change the direction of the sign. Negative 7y plus 8y is a y. 7 minus 7, that goes away. And notice here, we've isolated the variable. So one thing that we can do is we can flip this guy around. It doesn't really matter. It's fine the way it is. 2 is less than or equal to y is the same thing as y is greater than 2. So 2 is less than y is greater than 2. This one here just seems, I don't know, it looks better to me. I don't know why. It could just be the way I am. But once we've isolated the variable, put this in set builder, put a line, a y, scribble, and we're done. Now because y is greater than 2, we can think about putting this directly in interval notation. The point of interest is 2. We're not including 2 because we just have greater than. Because y has to be greater than that, this is the interval that goes from 2 to infinity. So that's the interval right there. This next one, once again, we have numbers and letters. So let's go ahead and get our x's to the left here. So subtract 2x. And we need to get rid of that 18, so subtract 18. So here, 3x minus 2x is x. 18's cancel. We have less than or equal to. Here the 2x's cancel. And then here, if we have 16 minus 18, that's negative 2. So we've solved this inequality. To put this in set builder, put a line and x and scribble. Now, because y is less than or equal to negative 2, less than or equal to means we're going to have a square in bracket. And because it's less than or equal to, we're coming from the left, so we're going from negative infinity up to our 2, and we're including that. So notice, these have the same solution set, and they also would look the same in set builder notation. Okay, so moving on to these last ones, we're kind of combining a couple different things in each of these problems. So here the first thing we need to do is we need to get rid of the grouping symbols. So I'm going to do some distribution. 7 times our 5x is 7 times our y is 35y. 7 times our negative 2 is negative 14 is greater than. We're not changing the sign, we're just distributing here. Distribute this. 6 times y is 36y. And then 6 times negative 1 is negative 6. So now it's time to get the variables on one side and the x on the other. Now, because we have 35y here and 36y here, there's more y to the right. I'm going to move my y's over there. So subtract 35y. And because we're moving our y's to the right, we're going to move our numbers to the left, so we add 6. So 35y and 35y, that cancels. Negative 14 plus 6 is negative 8. We haven't multiplied or divided by a negative, so we don't change the direction of the sign. Then 36y minus 35y is y. So we can say negative 8 is greater than y, but for some odd reason it just makes more sense to me if I say y is less than negative 8. So to put this in set builder, line, y, scribble. We could graph this to get this in interval notation, but I notice that if y is less than negative 8, we're coming from the left, so this is going to be the interval that starts at negative infinity, goes to negative 8, and because we have less than, not less than or equal to, we have a parenthesis there as well. Now the last one we have here is negative 6/5 is greater than negative 4x. Now when I see fractions, I like to make everything fractions, so I'm going to say this negative 4x is negative 4x over 1. Okay? So one thing that we can do here is we can multiply it through by the lowest common denominator, which between 5 and 1 is 5. So if we multiply both things by 5, that's a 5 over 1 and a 5 over 1. We're doing the same thing to both sides, it's fine. Now we're multiplying by a positive number, so we don't change the direction of the sign, we leave it there. Now this 5 cancels with that, leaving me with just negative 6. Over on this side, 1's in the denominator, so we just multiply. 5 times negative 4x is negative 20x. Okay, now the next thing that we want to do here is we want to isolate the variable x, so divide by negative 20. But because we're dividing by a negative, the first thing we want to do is change the direction of our sign. We divide it by the negative 20, which gives us x. Now a negative divided by a negative is a positive. Make those positive. And we can simplify this a little bit. That is, there's a 2 that can divide into the 6, giving us a 3. There's a 2 that divides into the 20, giving us a 10. So we get 3/10 is less than or equal to x, which I don't like that. I flip that around and say x is greater than or equal to 3/10. Put our line here and our x. Scribble. We're in set builder. And now I can do the same thing by putting this in interval notation and thinking x is greater than 3. So we're going to the right. So because we have greater than or equal to, square in bracket, starting at 3/10, and this is going to positive infinity, And that's how you do that one. So hopefully that's it. See you next time.